So we are talking about using logs to solve or solving logarithms. Kind of depends on how you look at it. So there's kind of two categories broken into two different sections. When there's logs on both sides of your equal sign and when there's logs on one side, they're very similar. You kind of do them a little bit differently, but they are pretty similar. Both sides. And what I mean by that is we have this equal sign, there's logs on this side, and there's one on the other side. So when I say both sides, it's both sides of that equal sign. This, I kind of put the instructions there, or I didn't write it out as steps, but the first part, or the first step, would be simplify into a single logarithm. So that into a single logarithm, and we did that the other day. We had that on the quiz, just using those properties to combine those. That means there's one log on each side, then you can literally forget about the logs and solve. So what this is very similar to is exponents. When we had 4 raised to the x is equal to 4 raised to the x plus 4, you could, since the base numbers were the same, you could set the exponents equal. That's essentially what we're doing with all these problems where there's a log on both sides. We're combining it to make it a single log. Once we do that, everything else you can just set equal to each other. For example, I did start this right. Okay, good. So first, we have log base 2 of x plus log base 2 of 4. Since it is a plus sign, the x and the 4 we can combine. We multiply those to get 4x. Now, this is where it turns into a problem we're talking about with your exponents. Since they both have the same base, log base 2 of 4x and log base 2 of 8, since it's both log base 2, then the 4x and the 8 have to be equal to each other. And again, it's the same concept as we did with exponents. And actually, the easier one we did, I can make it look like this one. 4x and 8. If the bases are the same, obviously 4 raised to the 4x, 4 raised to the 8, that means those are equal. Same thing. We're not as familiar with logs, but log base 2 and log base 2, those are, which means the 4x and 8 have to be equal to each other. So once we get to this spot, just set up 4x and 8, and then solve out like normal. X is equal to 2 for this one. Next one, same type of thing. Now, I will tell you, do not fall into this trap where you divide both sides by 2. If we're being honest with ourselves, that's not wrong. It just won't help you get your answer. I mean, you're dividing both sides because we're multiplying. So yes, that is actually very correct mathematics, but it's not going to help us find our answer at all. And we have to remember those properties where we take that 2 and we put it up as an exponent. So it's going to be log base 5 of x squared is equal to log base 5 of 49. Now that you have that log on both sides, now we do it the same way as the other one. Since they're log base 5, since they're both log base 5, we're left with x squared is equal to 49. And now we solve that just like normal. Take the square root of both sides, we get x is equal to, try not to forget, it is plus and minus 7. Since it is an x squared that we are canceling, whether we positive 7 or negative 7, that should work. I think. If I had extra time, I would plug it in because you can just plug it in to check your answers. But maybe next time. As long as I put a disclaimer in there, clears it up, right? So again, it's a little bit busier, but still same steps. I put the 2 up as an exponent. So this is log base 11 of 3 plus log base 11 of x squared is equal to log base 11 of 48. Now we can combine the 3 and the x squared since it's plus. We are multiplying those. Log base 11 of 3x squared. Now, finally, we have just one log on the left, one log on the right. So since they're both log base 11, we can set those equal to each other, the logs, and then we can solve this just like normal. Both sides by 3, x squared is equal to 16. Same thing we just talked about, take the square root. But remember that means it's plus or minus 4. we'll look into that sometime today. Number 4, they do not have base numbers, but remember, they don't have base numbers and in there because it makes you more comfortable. Obviously, you can do that. The problems, I don't put the base in, the base 10, because if we were changing to exponent form, there's a 10 there. But for this one, as long as we know they all have the same base, that's the main thing. So this one is subtraction, so now we're doing division. So this is log of x over 4. Make sure you have that right order. And log of 8. Again, since they're both log base 10, we can set those equal. And this, multiply both sides by 4. We're going to be getting x is 32. A lot of different examples, but I thought it was good to show you kind of some variety with that. But again, the punchline is using the same properties we learned in the last lesson. Get the logs together so it's just a single log, and then we'll set those equal to each other. And again, to set them equal to each other, they have to have the same base, but I'm not going to try to trick you. I'm not going to give you any that don't have the same base. That'd be maybe a good extra credit question, but I probably won't use it for extra credit. Any questions on those when you have the log sides? All right, so the next one is having the log on one side. I personally don't actually know which one is easier. I'll leave that up to kind of you guys to decide. So we start into a single logarithm. And once we do that, we're going to put in exponential form, and then we solve like we've done before. So we do that here in a second. So we have log base 4. So again, it's adding, so we can multiply 8 and x. This is where, again, some students get confused because now is where they just forget the log base 4. You can only forget about that if there's also a log base 4 on the right-hand side. Since there's not, we can't do that method. However, now it's set up pretty nicely since it's to go ahead and put in an exponential form. So 4 raised to the 3 is equal to 8x. Always my favorite where I'll have students that see this and they're like, well, but Mr. Stefan, I have no idea how to solve that because we haven't done exponents yet. Well, if the variable was with the exponent, it would be a little bit more challenging, but it's not a variable. Just take 4 to the third and solve that like normal. 4 to the third is just some normal number. That's 64. So is equal to 8x. Divide both sides by 8. X is equal to 8. So again, that's why I don't actually know which one I think is easiest. They all have their positives and negatives, I guess. But all you have left is an equation. The other one you have to use exponential, or you have to put it as an exponential equation. So same thing, number 6, that 2 has to go up as an exponent. So log, and then again, this is base 10. If you want to put it in there, you can. This one's not a bad idea to put the base 10 in there, and I'll talk about that in a second. So then we multiply. So this is log of 4x squared is equal to 2. And this is why I tell you, this is why I want to put in a base 10. It's not a bad idea because now I'm putting an exponential form. And so for some of you, I think it helps to see that 10 in there. So it's 10 squared is equal to 4x squared. So 10 squared is 100. It's equal to 4x squared. Divide both sides by 4. You get 25 is equal to x squared. And then again, from here, you just take the square root of both sides. We get plus or minus 5. Don't try to solve this one by taking the square root of both sides like this. Never mind. I think that actually maybe does work. I was trying to do it in my head, and you guys know I'm terrible at mental math. I would advise against it, but I do think it does work. And number 7, the last, take that 2 up as an exponent. So it's log base 10 of x squared is equal to 2. And that's 10 squared is equal to x squared. And again, from here, you can do it the longer way where you take both sides. Or take the 10 squared. That's what I would do. to take the square root. X is equal to plus or minus 10. Also, again, 10 squared is equal to x squared. A little bit of shortcut. But again, if you do that shortcut, I think it's hard to remember that it's plus or minus 10, which I will still check on. Any questions on those two methods? I know that thrown at you, but I didn't want to do a couple problems and have you do 3 on your own, then do another couple and have you do 3. I just didn't know if you had time for that, essentially. So go ahead and do these next 2 on your own. Again, one has log on both sides, one of them doesn't. If you have any questions, let me know. All right, my answers are up there. If you want to double check those quick. I honestly, in my opinion, I think this is one of the harder lessons we've done for a while. I guess maybe the last one was still maybe a little bit difficult. But again, it's not anything out of the, I don't think it's the worst thing that's ever happened. But there's just a lot going on. And again, you just have to make sure you remember, if there's logs on both sides, make into a single logarithm, and then you forget about the logs. If there's only logs on the left or only on the right, get it into a single logarithm and then turn it to exponent form. The important discovery I made, fun fact, obviously, for what it's worth, if you mess this up, I will not count you off, but there should not be pluses or minuses for these. If you look at the graph, the log of a negative number, I'm sure I learned that probably Mr. Ulrich probably told me when I was you guys' age. But for what it's worth, just use this as a good math opportunity for learning. It was a super easy one to figure out. All I did was I literally took number 7 and I put it in my calculator. I took 2 log of 10 and hit equals, and it gave me 2. Then I hit 2 log of negative 10 equals, and it said error, non-real number. So if you actually look at the graph, no negative. There's a asymptote for that. We talked about that a little bit. But anyways, if you put the plus and minus, I'm not going to count you wrong. I've tried to drill in that plus or minus rule you guys' head long enough that if you put it, I'll probably put an X through it, but I'm not going to count you off. But you can relax and you don't have to worry too much about that. Okay. So the next part of the lesson, not to be a super nerd, but it's part of exponentials and logs, is we're going to learn a new way by using logarithms to solve problems like we've done before. So if you look at this problem we had before, we have 4 raised to the x is equal to 1,024. And so the way we did that was we took, we made these both have the same base. 4 raised to the x is equal to 4 raised to the 5th. Then we set the exponents equal to each other. Now, I know the other day I told you guys you could skip this step because I know some of you guys, once you know that it's 4 to the 5th, you can skip to that. That's fine. I get that. But just because I didn't want to make it a super complicated problem, I still want to show those steps. So that's how we learned how to do it, where we did it by hand. The only problem with that, and we'll talk about this later, what if that doesn't work out? What if you can't find a base that's the same? So the other way we can do it is we're going to use logs with our calculator. And we can either use log. If you look on your calculator, it says, it's all capital, says log. And then probably on mine, it's right under that, but somewhere up, down, left, or right. There's another one that says ln. That stands for the natural log. We will talk about that here in a second. But both of those, we're going to take advantage of those because they are buttons on our calculator. So the way we're going to do this one is you can do whatever you want to any problem as you do it to the right. So if you want to take, if I wanted to add 10, that's fine as long as I did it to the left and the right. Well, we're going to stick with that same rule. That same rule we learned back in Algebra 1, balanced equations. I'm going to take the natural log of both sides. So I represent that with an ln. If you want to use log base 10, you can, if that one's easier. I use natural log because we're going to do something, tomorrow's Thursday? Yes, tomorrow we're going to do something where we're going to use natural logs more, so I would rather just get you started with that. But again, technically you can do what you want as long as it's the same base. So now we're left with the natural log of 4x is equal to the natural log of 1024. Now we're going to use that same property we talked about. The only difference is we're going to do the opposite. So remember, if we had x times the log of 4, you'd move that x to the exponent. Well, now we're doing the opposite. Now I can take that exponent and I'm going to move it out in front. So that's going to be x times the natural log of 4 is equal to the natural log of 1024. Then last but both sides by natural log of 4. So essentially, if you put the natural log of 1024 in your calculator, it'll give you an answer. It'll give you some decimal. So we can divide that decimal by natural log of 4, which is another decimal. So I typed this all in my calculator at one time. For you guys, it's probably not a huge deal because you'll probably use your fraction button. But in my calculator, it does natural log of 1024, and it puts a parenthesis there. If you don't put the other parenthesis before you do the division, it's going to mess things up. So I don't care how you type it in, but I know some of you guys have older calculators where you don't do the fraction button. That's fine. Just make sure you put that parenthesis on this side, or else it's going to mess things up. So you just type in natural log of 1024, put that parenthesis, divide by parenthesis if you need it, divided by the natural log of 4. Hit that twice. And that should give you 5. Now again, without def, log, again, you can use log. You could also use log base 2 on both sides or log base 8 on both sides. It's just that that button's not in your calculator, log base 8. And so natural log and log are just their actual buttons. You don't have to search for them. You don't have to do anything too complicated. So that's why we use either of those. And I'm going to stick with the natural log. So, really quickly, did I play on this guy? Good. Always makes me nervous. So why do we need to know both ways? Because that's one of the things where students always say, well, why did you teach me both? And the whole reason, actually, that's a really good example, just the ones we looked at. This way is really quick because this is a pretty easy problem. It was a little bit more of a nightmare. We still got the same answer. But the only reason that worked out is because, again, I could represent 1024 base of 4. A lot of problems you'll see. So like the example I gave, this way, I'm not going to do the whole thing, but it'd be easier the old way with this one because I know I can make 27 into the third. Maybe I messed that one up. Oh, I'm good. That was close. So you can make that into 3 to the third, which means you can have the x minus 4, and then we have the same base so we can work with it. So that's the reason that might be easier the old way. But again, the reason is because you can make 27 have a base of 3. If you look at this other one, there is no 215 on there. And you can't break 4 down into 2 squared because, again, you can't make 215 have a base of 2. So this problem, you have to use the logs or the natural logs like I did up here because it's going to give you a weird decimal answer, and there's no way you can make those two have the same base. You could use trial and error, and actually I think that was the extra credit on the quiz yesterday. I expected you guys just to use trial and error until you finally got it because we haven't learned this method yet. But trial and error, but that would also, especially if I tell you to go to like 4 decimal places, that'd be a nightmare. So definitely use your calculator for this. Now again, I know it takes a little bit of time and it's a little bit strange, but it's not too bad. I think this is probably the easiest part, in my opinion, of today's lesson. And also, to end with, start this, I don't care which way you use. So on a test, when you get to a problem like this, if you want to use it the natural log way that we're going over, you totally can. That's up to you. So if you just want to use your calculator on all of them, take the natural log of both sides. With the natural log of 5 raised to the x is equal to the log of 675. Again, if you would rather use log, you can. Also, you don't necessarily have to use a cursive L. I just do that so it doesn't look like 1. That property that says if it's an exponent, I can put it down in front. So it's x natural log of 5 equal to the natural log of 675. From here, divide both sides by natural log of 5. Just like a problem. And then in my calculator, either use the fraction button or use division. Natural log of 675 divided by the natural log of 5 is 4.05. Please round to 2 decimal places. Technically, it was 4.047, but that 7 rounds that 4 up to a 5. Sometimes you guys' rounding capabilities makes me a little bit nervous, but not over 2 standard, so not my problem. The next one, 7 raised to the x is equal to 700. Again, don't make it harder than it is. Take the natural log of both sides. And actually, for me, I would not mind if you guys do this in one step, where now you take the x in front. So it's x times the natural log of 7 is equal to the natural log of 700. Then divide both sides by the natural log of 7. Whoops. Natural log of 700. Again, I use division. If you use the fraction button, that's completely fine. I end up getting my x is equal to 3.366, so 3.37. So those are the most basic problems like that. Now, they might throw in a wrench where they throw in where number 12 has a +5, number 13 has some things up with the exponent. Don't make those harder than they are. They do take longer, and so, yes, there is a little bit more room to make mistakes. But, again, it's all calculator stuff. So don't let decimals scare you. Don't let any of that other stuff worry you. It's just more to put in your calculator. So what we'll do is get that exponent by itself, so I subtract 5 from both sides. 0.25 raised to the x is equal to 1877.8 minus 5. Again, I just use the calculator. And then from here, take the natural log of both sides. X goes in front. Natural log of 2.8. And again, just like the last one, divide both sides by the natural log of 1925. 19.25. So, natural log of 1872.8 divided by the natural log of 19.25. 2.55 is your answer for that one. Now, again, I know that it looks like there's a lot going on. This is one of the reasons I like this when I was in high school, because once you get the hang of it, it actually is really much different than some of the other problems we've done. But I feel like it makes you look really smart, because there's natural logs going on that most adults probably don't know about, forgotten by at this point. But really, if you look at the basics, we're not doing a lot. We subtracted 5. And then again, yes, we did take the natural log of both sides, but that's just to move a number down. And then we just use division. So again, I know it looks weird, but the basics really aren't too bad. The next one even is a little bit longer. I add 72 to both sides. 13 raised to the x minus 10 is equal to 1,272. Now, I know there's an x minus 10. Don't make that anything crazy. Still stick with the same script. Take the natural log of both sides. That x minus 10 moves in front. Then again, just like before, divide by the natural log of 13. Divide by the natural log of 13. I'm going to run out of space here. Oh, I might have some room over here. Now, if you want to, at this step right here, if you want to find what the decimal is because you don't like that being super messy, that's totally fine. I don't prefer to do that just because years of training to not round. But if you want to go ahead and find the decimal, you can. But this ends up being x minus 10 is equal to
natural log of 1272 over natural log of 13. Then last but not least, all I do is add 10 to both of those. So in my calculator, I take the natural log of 1272, the natural log of 13, and then I always hit enter. You don't necessarily have to. You can use, I mean, again, with your fraction button, I think you probably could put it all. But then I add 10 to that. That gives you x is equal to 12.79. Now, honestly, you will not see that very often. I just kind of wanted to show you one of those upper level problems like that. But again, once you get the hang of it, it's really not too bad. It's just, again, honestly, I think I probably should have done it. It might help you guys just to go ahead and make this a decimal. So when you add 10, you're just adding 10 to a decimal. Whichever you prefer is fine. But again, the biggest thing is once you get the hang of this, it's not much different than what we've done before. I will tell you, I'm sure you could do this when there's a log on both sides, but primarily this is going to be used when you only have when you have an exponent on both sides. Primarily we use this when there's only an exponent on one side. I'm sure, again, you probably can do it both ways. It just might be more confusing. So go ahead and do those two on your own. Number 15 is just like the last one we did. However, 14 shouldn't be too bad for you guys at this point. Up there, not that you guys would be actually curious at all about this, but if you wanted to put in your calculator natural log of 816 over natural log of 4, if you put that same thing in, except for use your log button instead, log of 816 over log of 4, it'll give you the exact same answer. Because like I said, it doesn't actually have to be natural log. It doesn't even have to be log. It's just how you have to use the same thing. So if you want to do log base 2 of both sides, you could. Those are just not super handy in your calculator. The other one I did, number 15, I did that other way where I just went ahead and found the decimal with this one, so it wasn't as messy, and I subtracted 4 from both sides. Again, I'll be leaning on that. It was just very much drilled in my head through all my math classes to not round until the very end, so you don't make things inaccurate. But it's algebra too. It's not multivariate calculus.